Hello and welcome to my all of iGCSE Maths Paper 2, the 2025 edition. That's right, so this is really focused on non-calculator topics, those topics that are much more likely now to appear on the Paper 2 rather than the Paper 4. And there are four key ideas to this. So first of all, as I just mentioned here, the non-calculator aspect. It is based on the specimen papers, so what's been coming up in the specimen papers. Third, my prediction videos. So I do these prediction videos every year for the last 3 or 4 years. Again, you can check out the most recent one above me here. And then number 4, which is really important to yourselves here, which is the harder topics. Now, not every topic is really hard, but certainly things like differentiation and vectors and things like this, I'll be talking about in this video. So get yourself a coffee, get yourself a tea, sit down for the next couple of hours or so and work through these topics so you're really prepared for those harder topics on iGCSE Maths Paper 2 in 2025. Right, let's get started. Okay, so let's go through some typical Paper 2 questions, and all these questions that you see today come from the last 3 years of papers. So find the x-coordinates of the point, note the coordinates, of the points on the graph of y equals x to the power of 5 minus 5x to the power of 4, where the gradient is 0. So you usually give some indication of either a turning point or where the gradient is 0. So this is the thing to look out for when looking for a differentiation question. So what we're going to do is we're going to take our function and we're going to work out the derivative, dy by dx. Now the process that we do here to do this is we take the 5, we bring it to the front. So I'm going to bring the 5 to the front, and now we reduce the index by 1. So what do I mean by this? Well, we're going to reduce this from a 5 to a 4. And this is the standard process for differentiating at iGCSE. This one here, well, we're going to take the 4, we're going to bring it to the front. So what does that mean here? Well, we need to do 5 times 4, and that's equal to 20. And then we reduce the index by 1. So we get x to the power of 3. Now in the question, we want to find out where the gradient is 0. Notice dy by dx, this is what's called the gradient function. So we want to take the answer we just made and make it equal to 0. So we need to solve this equation here. Now, this is actually an equation which we can put into a single bracket. So what do these two things have in common? Well, they have a 5 in common and they have an x cubed in common. Because notice x times x times x also fits into this as well. Then we open up our brackets. We say to ourselves, well, what do we multiply 5x cubed by to get 5x to the power of 4? Just x. What do we multiply 5x cubed by to get minus 20x cubed? Well, that's just minus 4. And now we use the null law. So either this has to be equal to 0 or this has to be equal to 0. Because you have two numbers or two things that multiply to give you 0, then one has to be 0. So either, this is the way I like to write it, either 5x cubed is equal to 0, which means that x then has to be 0. It's the only thing that works. Or x minus 4 is equal to 0, and therefore we solve the equation x is equal to 4. And notice all they wanted for this question are the x coordinates. We don't need to work out the y coordinates in this case. So our answers here are x is equal to 0 and x is equal to 4. So we write that in. However, in our next question we're going to look at on a paper 2, they sometimes ask you for the actual coordinate itself. Let's look at that now. So we want to differentiate 6 plus 4x minus x squared. So we need to differentiate this function. So let's go through that process now. Now, if you have a number and differentiate it, it disappears. Okay, so we're going to ignore that. If we differentiate this, well, we still use the power law as normal. Notice x on its own is the same as x to the power of 1. So we bring that 1 and bring it to the back. 1 times 4 is 4. Reduce the index by 1, so x to the power of 0. Now some of you already know what the answer is, but I'm just going to write it out in full. And if we differentiate the minus x squared, well, the 2 comes to the back. So we get minus 2 and then we reduce the index by 1. Well, let's reduce that down from 2 to 1. Now at the moment it's in kind of ugly algebra, so let's tidy this up. So remember, anything to the power of 0 is equal to 1. 1 times 4 is 4. And remember, x to the power of 1, we generally like to write that as x. So our answer for this question here is 4 minus 2x, like so. And now we need to work out the coordinates of the turning point. So that's when the gradient is equal to 0, kind of the other way around to the previous question, of this function here. So we want to set our gradient function, 4 minus 2x, our dy by dx from the previous question, equal to 0. So this is a straightforward equation to solve. I'm going to minus 4 on both sides of the equation. This cancels. We get minus 2x is equal to minus 4. And if we divide by minus 2 on both sides of the equation, this cancels and we're left with x is equal to 2. Now notice that's not our final answer. That is just the x-coordinate of the turning point. To work out the y-coordinate, we need to sub x equals 2 into here. So we need to then do y is equal to 6 plus 4 lots of 2 minus 2 squared. And if we work that out, well, 6 plus 8 minus 4. Remember your bid mass. 6 plus 8 is 14. 14 minus 4, well, that's equal to 10. So our final answer for this question is then 210. So you need both the x-coordinate but also the y-coordinate there as well. And you can have a look at the mark scheme. This is where you pick up your method marks if you go a little bit wrong right at the end. And so we're going to look at this one here. As you can see, it's out of 8 marks, so it's going to take a little bit more work. So first of all, we want to work out dy by dx of this function here. So the way we do that is just like we did on the paper 2 questions. So we take the 3 here, we bring it to the back. So 3 times 2 is equal to 6. We reduce the index by 1, so it was an x cubed, and now it's going to become an x squared. And likewise for this part here, we're going to take the 2 there, we're going to bring it to the back. Minus 4 times 2 is equal to minus 8. We reduce the index by 1, so this becomes x to the power of 1, or as we like to write, just x. And that's all we need for our derived function. Remember, if you differentiate the 6, then that gradient of that is 0, so that will disappear. And now this is very typical in the part 2. We want to work out the gradient at a specific point. So we want to work out the gradient when x is equal to 4. So we take our initial answer here, so 6x squared minus 8x, and replace the x with 4. So we get 6 lots of 4 squared minus 8 times 4. And remember our bid mass, so 4 squared is equal to 16. 8 times 4 here is equal to 32. And now we just need to do this calculation here, so 16 times 6. Now, again, we've got a calculator, but again, you can always do it manually this way as well. This gives you 96. So then 96 minus 32. Again, any of this can be done on your calculator as well. And this gives you the final answer of 64. So the gradient at that particular point is equal to 64. And this is a good question to go through because it goes through a lot of the typical kind of paper 4 style differentiation questions. And we want to work out the coordinates of the 2 stationary points on the curve. So as soon as you see the phrase stationary point or turning point, you need to be thinking that the gradient function, that's a T, gradient function is equal to 0. Well, what does that mean? So we take our initial function here, our 6x squared minus 8x, and make it equal to 0. So you need to have good quadratic skills as well in order to be able to do these questions. Now here, this is an example of where we factorize into a single bracket. So what do these two things have in common? Well, they've certainly got a 2 in common, and they have an x in common as well. So then we open up our bracket. What do we multiply 2x by to get 6x squared? Well, that's going to be 3. 3 times 2 is 6, and an x. What do we multiply 2x by to get minus 8x? That's going to be minus 4 is equal to 0. And just like we did in one of the paper 2 questions, we use our null law. So when 2x is equal to 0, so we know one of these things has to be 0, we don't know which one. Well, x is equal to 0, and when 3x minus 4 is equal to 0, well, 3x is equal to 4, x is equal, oh no, so near the bottom of the page, is equal to 4. It doesn't want me to write it, I'm going to write it over here. See, there we are, 4/3. That is going to be 4/3. There we are. I'm determined to write it. There we are. So x is equal to 4/3. So that's our x coordinates of the turning points. So 0 and 4/3. And now we need to work out the y. So we need to take our function right up here. So this is equal to y equals 2x cubed minus 4x squared plus 6. And now we need to replace the x in here with these values of 0 and 4/3. So let's start with 0. So when x is equal to 0, y is equal to, well, that disappears. That's cool. This also disappears. That's even cooler. And we've got the plus 6. So these all disappear, and we're left with just 6. So our first turning point, or our first stationary point, is equal to 0, 6. Next one's going to be a little harder. So we're going to go to when x is equal to 4/3. I'm going to just write this out for the examiner. So we've got 2 lots of 4/3 cubed minus 4 lots of 4/3 squared plus 6 to work out these more complex calculations with fractions, and that gives me the y coordinate of the other turning point, like so. So there's the mark scheme, so you can have a quick look through and where you actually get the marks and what some of the method marks are dependent on as well. Okay, on to the next question. So again, this is very, very typical of the paper 4 and the 0580 course. They don't start necessarily with a differentiation problem. It's usually embedded in another question. So in this case, the equation is cubic, x cubed minus 4x squared plus 4x can be written in this form. Find the value of a. So cubics, generally speaking, will be written in such a way so you can factorize this quite easily. So notice they've all got a factor of x here. So we're going to take a factor of x out. What do you multiply x by to get x cubed? X squared. What do you multiply x by to get minus 4x squared? Minus 4x. What do you multiply x by to get 4x? It's just plus 4. At this point, we've got a quadratic within the bracket. So at this point, we can put this into 2 brackets. And we put an x at the front, an x at the front. And we want 2 numbers that multiply to give me 4, but add to give me minus 4. Well, that's going to be minus 2 and minus 2. And notice, because you've got 2 x minus 2's, this can be simplified further as x minus 2 squared. Now, that's not the answer that they're looking for. The actual answer is, what's this missing value a here? And notice it's the value of 2. Now, one of the reasons they've done this in the first part is now we can now draw a very nice sketch. So if I was to solve this equation, so let me pop this over here. So x over x minus 2 all squared times x minus 2 all squared is equal to 0. Then using the null law, I know then that x must be either equal to 0 or equal to 2. However, this is a cubic. So remember that the shape of a cubic, generally speaking, looks something like this. So it crosses the axis 3 times. This is a very special cubic where it only crosses or touches the x-axis twice. So let's mark in those turning points. So we've got 0 here and 2 over here. We have a positive cubic. Notice this is an x cubed. And so we've got all the information we need to draw a good sketch. So watch carefully. We're going to go up, 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 up. We go through the point, and this is the crucial part because 2 is a repeated root. We're just going to touch the graph there, and then we go off. That's a little bit of a bend there. Try and make sure that's a nice smooth curve as well. Okay, so notice that I've followed the instructions of the question, where the graph meets the axes, where it meets it at 0, 0, meets at 2, 0 as well. But there is some sort of local maximum, but that's not necessary for this question. You'll see in the mark scheme, if I go forward to the mark scheme. So here's your graph. So it's going through the origin, going through 2, 0, the positive cubic, and it's the right shape as well. So you can see I pick up all 4 marks. Now comes to the differentiation part. So they take that cubic, and we want to find the equation of the tangent to the graph at x equals 4. So what that means in real English is if I take go green, x is 4 is probably up here somewhere. Okay, so if we read that off, that's 4. So basically, at that particular point, we want to find the tangent line. So the line that just touches the curve and then disappears off. So this really, really steep line. And we want to find that equation of that particular line. So the way we do this is we use some differentiation. This is where it's embedded. So first of all, we need to differentiate the function. So we get dy by dx. So remember, we take the 3, bring it to the front, reduce it by 1. So we get 3x squared. We do the same procedure here. I'm speeding up slightly now. So minus 4 times 2 is equal to minus 8. Reduce the index by 1 is 8x. And don't forget, because you've got a 4x here, we do the same procedure because this is a 1. 1 times 4 is 4. And then reduce the index by 1. That's x to the power of 0, which is just 1. So we get the function of dy by dx is equal to 3x squared minus 8x plus 4. Now at this point, we actually want to work out the gradient at the specific point. We don't want to work out turning points or anything. So we need to work out d by dx, where x is equal to 4. What does that mean in real English? Well, we're going to put 4 into this equation. So we get 3 lots of 4 squared minus 8 times 4 plus 4. Well, 4 squared is 16. 16 times 3 is 48. 8 times 4 is 32 plus 4. And that simplifies to 20. Okay, so the gradient of that green line that I drew over here, let me just mark this in. The gradient of this line is equal to 20. So we've got that information. Now that means that the tangent line, so I'm going to write the word tangent, has the form y equals 20x plus c. And now we need to work out the y-intercept, this c. Now the only point that we know on this particular tangent line is this point here. Okay, and we know the x-coordinate is 4, but we currently don't know what the y-coordinate is. The way we can work that out is actually substitute x equals 4 into this equation. So when x is equal to 4, y is equal to 4 cubed minus 4 lots of 4 squared plus 4 times 4. That's a lot of 4s. That is definitely a lot of 4s. So we get 4 cubed is equal to 64. Well, 4 squared is 16. 16 times 4 is 64. Oh, that's nice. That cancels. And then we get 4 times 4 is 16. So when x is 4, y is 16. So this coordinate is actually 4, 16. And now we have enough information to work out c. So when x is equal to 4, y is equal to 16. You can see why this is a 7-mark question. A lot of work involved. So we've got 16 equals 20 lots of 4 plus c. So 16 is equal to 80 plus c. And then c is equal to 16 minus 80. This is really where you don't want to make a silly mistake, by the way. So 16 minus 80, that's equal to minus 64. So our final answer is equal to y equals 20x minus 64. And you'll see that agrees with the final answer at the end for all 7 marks. So just be very careful of that kind of calculation right at the end. You're going to be tired at the end of a question like this. Make sure you're accurate all the way until the end. Hello and welcome to another Ginger Mathematician video, and today I'm going to go through iGCSE Advanced Vectors. I did a similar video on mensuration with advanced mensuration, and I thought I'd do exactly the same for vectors as well. Now if you're really not sure about vectors, again what a vector is and doing those basic calculations with vectors, then please do check out my Udemy course on vectors. It's completely free and that will get you up to speed on what you need to know for iGCSE vectors in general. But I thought I'd take some more advanced questions. I've had a lot of requests for a video like this, so you can go through this nice and carefully. Right, let's get started. So we have a diagram that shows a triangle OAB. So we've got O here, A and B, and a parallelogram over here, so OKAL or OALK. And the position vector of A is A, and the position vector of B is B. So that's already marked on here. What it's basically saying here, this word position vector, we're going to talk about this a lot in this video, often confuses students, but all a position vector is, it's the vector from O to A. So O to A is just vector A, and the vector O to B is just B. The O here is just the origin. It's the center point where we're working from. Now K is a point on AB, so this straight line here, such that the AK, the ratio AK to KB is 1 to 2. So what that means is, remember with ratios, if we do 1 plus 2, we get 3. So that means a third is represented by this section, and 2/3 is represented by this section from B to K. So putting in all that key information just to help us when we actually work out what the question wants us to do. And what it wants us to do is work out the position vector of L. So remember, the position vector, just like I mentioned here, we're starting from O, so we're looking for OL. Now, in order to go from O to L, we have a couple of options. One option is to go from O to A and then go A to L. So we could do that. Or we could go O to K, okay, plus KL. So we can take either of these routes up here in order to work out the problem. Now, because this is a parallelogram, so this is an important word in the question, it basically means that the vector OA is going to be the same as KL. Okay, they're the same length and direction. So I can actually write this in as well, that this vector is also going to be A as well. So it means I can take either route and it's not really going to make much difference. Okay, so this is the way we try and use this sort of retrograde thinking. I want to work out OK, that's really important for the question. Before I can work out OK, I need to work out, well, to go from O to K, I need to go O to B and B to K, for example, or O to A and A to K. So I need to work out this vector BA or AB. So I'm going to have to, in some shape or form, work out this vector. I'll put it in blue here so you can see this nice and carefully. And I need to work this out, whichever direction that we go. I'll just take this direction, so from B to A. So how do I go from B to A? Well, to go from B to A, I can go from B to O and O to A. So I'm going to write that in, B to O and O to A. Now the vector B to O, because I'm going against the arrow, is going to be minus B, and O to A, I already know this is plus A. However, in order to work out this O to K, I need this section of my vector here in order to do O to B and B to K. So if I want to work out the vector BK in that direction, remember I wrote this down earlier, it's 2/3 of the entire vector, 2/3 of BA. So it's going to be equal to 2/3 of minus B plus A, and so that's equal to minus 2/3 B plus 2/3 A. Okay, so we're working through now, we're working forwards rather than working backwards. Now I can actually use this to work out OK, which was important from what I wrote earlier. So to go from O to K, okay, sorry, that joke is so bad. Then we go from O to B, and then we go B to K. Now O to B, I already know, that's just equal to B. And B to K is what we worked out earlier, which was minus 2/3 B plus 2/3 A. Now we're going to collect up some like terms. Remember, this is one lot of B. So 1 minus 2/3, that's going to be equal to 1/3 B. And then 2/3 A stays as it is. We collect up A separately and B's separately as well. Now, OK is not the answer we're looking for. Remember, we're looking for the position vector. We're looking for OL here. So to work out OL, just like I did above, we need to go from O to K, which we just worked out, plus KL, which we already know. So we have then 2/3 A plus 1/3 B. And then we've got this vector K to L. That's just equal to A. Now remember, we've got 2/3 A here. We've got a whole A here. So 1 plus 2/3 is 1 2/3, or 5/3 A plus 1/3 B, which is going to be our final answer. Make sure you got your squiggles on your vectors. That's really, really important to make sure you're indicating it's a vector quantity and not a number or scalar quantity. So you can have a look at the mark scheme here. Again, for all 4 marks, we've got our answer, and you can see where you pick up those method marks as well. Right, on to question 2 here. So they like their position vectors, yeah? OA and OB. So we're given that X and Y. And OD, so the vector O to D, is equal to 3/7 X plus 4/7 Y. And we need to calculate the ratio A to D and D to B, kind of backwards to some of the questions we're going to see today. Okay, so before we can really discuss this, I think we just need to work out our vector A to B. Notice that's always a very standard thing to do, the so-called long way to go around and find this vector. So A to B is A to O and O to B. So that's equal to minus X plus Y. You can write down minus X plus Y straight away once you're used to these kinds of questions. So in order to work out O to D here, we then just go O to A, and then some fraction of this line here, some fraction of AB. So let's just give that a number. Let's just call it K. So K lots of AB. We don't know how long we need to go along the line. That's what we're trying to work out here. So we have O to A, that's equal to just the vector X plus K lots of what we just worked out, which is minus X plus Y. Now we can expand the bracket here. So we just get X plus minus minus Kx plus Ky. And again, we can rewrite this slightly. So we can factorize out an x. So we get 1 minus Kx plus Ky. And we're told this vector OD, as is seen in the question here, is equal to 3/7 X plus 4/7 Y. So in order for this to be true, again, K must be equal to 4/7. In order to get this as 3/7. So our ratio here, so this is 4, the whole thing needs to total to give us 7. So therefore this needs to be 3, because 4 plus 3 is 7. So we have our ratio here of 4 to 3. Careful, not 3 to 4, but here 4 to 3, because we have this extra position vector in here as well. Okay, so you can check the answer here. Again, quick 2-mark question. Again, it's working backwards to what we've actually kind of seen already. Okay, and now we've got a bit of work with magnitude and subtracting vectors. Okay, a bit more on the easier side. So first of all, we want to work out P minus Q. If you've watched my Udemy course, I go through this in quite a lot of detail. So we've got 2 minus 1, and then we have 8 minus 4. So remember, 2 minuses here. This is what you have to watch out for to not miss a mark out. So minus minus is a plus, so we get 3 at the top and 4 at the bottom. And now it wants us to work out the magnitude of this vector. So this is something we'll talk about in later parts of the video. And remember, if you want to work out the magnitude of the vector, you want to do Pythagoras. So we put this into the Pythagoras formula. And again, this is quite nice numbers. If you spot the answer straight away, really well done. So we get square root of 9 plus 16. That's equal to root 25, and that's equal to 5. Again, if you notice that Pythagorean triple of 3, 4, 5, really well done. You can pop that straight in. As you'll see in the mark scheme here, Again, you get 1 mark for some idea of putting 3 and 4 together. Right, on to our next question. So we have a trapezium, not a parallelogram this time, so a trapezium, so you have to be a little bit more careful. O is the origin, OR is A, and OP is B. Okay, so we've got our position vectors here. And the magnitude of RQ, so let's look at this vector at the top here, is 3/5 of the vector OP. Now we know OP is equal to a whole B, so the top here must be equal to 3/5 B. This is a very common technique that I'm doing in these questions. Before I even look at the question, I try and fill in as much information as I have, so then when I come to the question, I've already got that information there ready for me. Now we need to find the vector PQ in terms of A and B. So we want to go, and let's put this in a different color. So here we are, so going from P to Q. And we're going to have to take the long route round, I'm afraid. So if we want to work out PQ, then that's equal to P to O. So we're taking the long way around here, P to O, O to R, and then R to Q. And by putting in that extra information, we can just put in all the information we have. So P to O going against the arrow, minus B, and we're going with the arrow, O to R, so plus A, and then we've got 3/5 B. Remember, this is minus 1B. So this simplifies then to A, and we've got minus 1 plus 3/5. That's going to give us minus 2/5 B. You need to be good with fractions when you're working with these kinds of vector question. So let's pop that in. We have A minus 2/5 B. Nicely done. Now this next question, a lot of people ask me about this kind of question, so do pay careful attention to this. So when PQ and OR are extended, they intersect at some random point called W, and we want to find that position vector of W. So we want to find OW, whatever that's going to be. So what does this look like? So P to Q is extended, so imagine it going up like this. And what else is extended? OR is extended. So at some point, and you can probably agree with this, it's going to meet at, resume that slideshow. It's going to meet, oh great, I have great fun with this. Okay, it's going to meet at some point W at the top. Now you probably agree here that if I do this in a different color, it must be to some vector just with A in it, because we're just going along this line. Again, we're just making the vector bigger or smaller, so we're changing the magnitude but not the direction. So this vector must equal to something A. We just don't know what that something is. Now, the way to think about these kind of problems is actually think of it in two different ways. So we know that OW, the vector O to W, is equal to some K times A. We know that from what I just described. However, we could also take a longer route. We could take the route O to P and then P to W. So we could take the vector O to P and P to W. This is where part A is very important for part B. Now the vector O to P is equal to B. And so this vector PW is some multiple along this line, a multiple of this PQ that we worked out before. So let's call this like some kind of T, we don't know what this T is, of that vector PQ. So let's write that in. So some T times PQ. So PQ was A minus 2/5 B. And let's just multiply out and collect stuff. So we get B plus T lots of A minus 2/5 T of B. Thinking why we're doing this, but you'll see in a moment. And then we collect up A's and B's together. So we have TA, and then we've got a 1 here, and we've got minus 2/5 T. We don't know what T is at the moment. B. So there's two ways of describing OW. Either the first thing, just some multiple of A, and that means 0B, there's no B involved, or TA, a different letter, plus 1 minus 2/5 TB. If these two things are true, then that means that the K must equal T, first of all, and that 0, most importantly, is equal to what I have here. We're doing basic equating coefficients. We use this a lot at A level as well. So what I can say is this 0 at the top here is equal to whatever's here. So 1 minus 2/5 T. That gives us a really easy equation to solve. So we get 2/5 t is equal to 1, and therefore t must equal 5/2. Again, this is an advanced video. I'm not going to go through that in much detail. And remember, I also said that t is equal to k, which is what we wanted to find. So our answer here will just be the position vector, OW, is just equal to 5/2a, like so. These questions come up a lot at the top end where there's AA star questions. And if you want to get those A stars specifically, these are the kind of questions you need to kind of get your head around and practice. So there's the mark scheme for the two things that we have already done so far. And you can check the mark scheme as well. What I'd like to talk about is a very similar question to the specimen paper 2. And that is a cubic function. However, if they give you a cubic function on iGCSE 0580 Maths, it will be in this kind of factorized form. So don't feel like you'll have to use a factor theorem, remainder theorem to do these. So let's talk about, first of all, the shape of the graph. Now, notice these x's. So if I multiplied all of this out, I would get x times x times x, which is equal to positive x cubed, or 1x cubed. Now, because it's a positive x cubed, so a is equal to 1, the graph goes uphill. So what do I mean by this? A general cubic has two different shapes. Either it goes this way, or for a negative, it goes this way. And because a is equal to positive 1, it's going to have this general shape here. Okay, so that's what I mean by going uphill. Imagine you start here and you're hiking and you're going all the way up to here. Then you're essentially going uphill. You've got a little dip here, but the general trend is that you're going uphill. So we know from the a equals 1 that the graph goes uphill. Perfect. So we can tick this off. Now we need to find the y-intercept, so set x 0. Again, we've looked at this before, so when x is equal to 0, y is equal to, well, 0, 0 minus 1, 0 plus 1, and anything times by 0 is just going to equal 0. So we've got our y-intercept at 0, 0. And now we need to find the roots. Now notice it's in a very nice form, which it will be for iGCSE 0580 Maths. So we have it in this form, and that means then that either this x is 0, which we already knew from the y-intercept anyway, x minus 1 is 0, so x is positive 1, and we also know x plus 1 is 0, so x is equal to negative 1. So we know it's going to cross at 0, at 1, and at minus 1 as well. So that is useful information to know. Now, I know a few people have asked about this, about how do you actually work out the maximum and minimum points. Now, as I put here, it's not usually required for iGCSE, but if you're moving on to other courses and you're looking really on that extension, those unseen kind of questions, let's at least talk about this. So if I expand all this out, notice we have it in the difference of two squares form. So if I leave this x alone, but just expand the bracket, well, we've got x squared plus x minus 1. These two cancel, and so we're left with x brackets x squared minus 1. So this is a difference of two squares. You should recognize that from the iGCSE course. Now we can just multiply out this bracket. So we get x times x squared is x cubed, and then x times minus 1 is equal to x. So if we expand all of this out, then we get this particular fairly simple cubic here. Now, to work out the maximum minimum point, we have this method called differentiation, which some of you have talked about in the chat already. So how do I differentiate this function? How do I work out dy by dx? Well, we take the 3, we bring it to the front, so that gives us 3x, and then we reduce the index by 1. So we go from 3 to 2, just like that. For this one, we do the same process. So we take the 1, bring it to the front, so we have minus 1, x, we reduce the index by 1, so that gives us x to the power of 0. Now, you should all know, this is a really important fact, anything to the power of 0, so x to the power of 0 is equal to 1, 7 to the power of 0 is equal to 1. My favourite football team, Derby County, they're in the second league, Hopefully they'll survive this season. To the power of 0 is also 1 as well. So anything to the power of 0 is 1. And so this term here just becomes minus 1, like so. So we've now found the derivative of the function. Now, why do we care about such things? Why do we care? The reason for that is to find any stationary points, so minimum or maximum. So I'll use min or max. We set our derivative now to 0. So we take the 3x squared minus 1 and we make it equal to 0. So we're going to solve that equation. So I'm going to give you a moment in the chat. Can you solve that equation for me? 3x squared minus 1 equals 0. Please be careful. That's all I'm going to say to you so far. Let's see if anyone can answer this. I'll take a little break and take a little coffee. Okay, so we've got our square root of 1/3. Can we be a little bit more specific here? So I agree, 3x squared is equal to 1. X squared is equal to 1/3. Good, plus and minus. Thank you, Hassan. Really well done. So we've got the plus and minus the square root. That makes a big difference for this kind of question. I'm sure your teacher has said when you find the square root of a number like 64 is equal to 8, that's the principal root is what we like to call it. But when it comes to equation solving specifically, then you get two answers. So there's a difference between just knowing a square root and square rooting in an equation. There are two different things going on. Nice. So we've got plus and minus the square root of 1/3. Now, just to test your surd knowledge, because that is also important for paper 2. So we've got plus and minus. We do the square root top and bottom. We get 1/√3. Can anyone tell me in the chat how I rationalize the denominator here? This is a phrase you need to know from surds. How do I rationalize the denominator here? Let's see if anyone can do that in the chat and know what I'm talking about, because it's really important. It comes up now, or will do a ton. So how do I rationalize 1/√3? What answer do I get? Trench has got the right idea. Can you give me an answer? Good, yeah, exactly. Well done. So we get the plus and minus the square root of 3/3. Generally speaking, you should rationalize the denominator if you get the chance to do it. Whether they take a mark off at iGCSE for this kind of question, I doubt it, but they certainly could do that. Now, once I know the plus and minus √3/3, once I know those two answers, I can substitute that back into my function to work out the y coordinate. Now, I'm not going to do that now, but if you wanted to work out the y value, we take plus √3/3, and then we can work out y, and then when x is minus √3/3, then we can work out the y coordinate there. So notice we're going to have a maximum point and a minimum point. Now I haven't talked about the second derivative yet, about working out if it's a maximum or minimum, but we can be a bit lazy in this question. And there's a reason why. Can anyone tell me why I don't need to use the second derivative test to work out which is a maximum, which is a minimum? So can anyone tell me that whilst I start drawing our sketch here? So let me just duplicate this slide. Can anyone tell me why I don't need to use the second derivative test? Okay. One is negative already. Yeah, I think you've got the right ideas. So let me just draw in my sketch. So, and this is why the y coordinate doesn't matter too much. I just want to show the knowledge here. So we've got, goes through 0, 0, goes through 1 and minus 1, wasn't it? Yeah, 1 and minus 1. 1 here, minus 1 here. Now, if you take the general shape of a cubic function, general shape, notice it will always have a shape when it's positive, like this. So I've drawn this best. Should be symmetrical, by the way, but that's a point for a different video. So notice the first point always has to be the maximum here, and the second point always has to be the minimum, because we know the shape of the graph. It's our very first thing that we did. So if we go minus √3/3, and whatever the y value is comes here, and then root 3 over 3, and whatever the y value is, then will come here. So you can use the shape of the graph to actually work out if it's a maximum or a minimum. Okay? But yes, you can use the second derivative test as well. But notice I'm trying to save you time in the exam. If they say, okay, I want you to draw a function and give the minimum maximum points, you don't want to be sitting there doing another derivative, substituting values in, seeing if it's less than 0 or greater than 0. This is a much quicker and refined way of doing it. So I'm trying to give you lots of tips in this video. So just to speed you up in the exam so you can get that extra time to really work on those difficult questions. Yeah, does this apply for 0607 paper? I don't think so, because you've got the graphical calculator for 4 and 6 anyway, but this is good knowledge generally to have when you go into IB or A level, okay? So, nice little trick to know for cubics. You can use the general shape to know where the minimum is and where the maximum is. Okay, any questions in the chat before we do a actual genuine specimen paper question based on what we've talked about so far? Could I do more mensuration videos? I've done 2. I've done an ordinary mensuration. I've also done an advanced mensuration video. So again, type in to YouTube, iGCSE mensuration ginger. They should come up. Hey, not related, but what questions are more likely to come in paper 2? Yeah, so something like exact trig values, the exact trig values, surds has to come in non-calculator. So there are certain topics that have to be non-calculator based. They don't ask minimum maximum iGCSE. Probably to calculate it, like I just did in this question. Probably not, but it's good knowledge to have anyway. And if they want to try and extend those A-star questions, which they always do some twist every year, like I predict the exams, and I predict it with like 60% accuracy, 60, 65%, but they'll always put something in there to try and really differentiate between A candidates and A-star. Atmas video, there will be one coming out fairly shortly. I'm not going to tell you which topic it is, but it will be coming out. Do they ask to find maximum in sketching graphs at iGCSE? Not that I've seen yet, but there's no reason why not. You have the skills for it. Prediction papers are already on my website. So you go Ginger Mathematician prediction papers into Google. You will find those for iGCSE, both paper 2 and paper 4, and A-level papers 1 and 5. Okay, so to finish this video today, we're going to do part 26a using what I've literally just said here. So on the diagram, sketch the graph of y equals f of x between our domain. So notice this word we should be more familiar with now. So what x is allowed to be. Now it's given, obviously, on our diagram, we're going between -3 and 4. So can anyone tell me what the first stage is? It's a 3-mark question. Probably takes you 4 minutes in the exam. What should I do so far? What should I do? Yeah, the prediction papers are paid for, but it's a way of supporting the channel. So it supports all the other content that I do, and there's tons of content out there. Expand! No, don't expand. Please don't expand. Please don't expand. Don't need to expand. Definitely don't need to expand. Okay, first thing, shape of the graph. First thing, shape of the graph. So we've got x times x times x. So we've got x times x times x. Yeah, if you expand, it just takes up too much time. It doesn't really help you too much. It's an x cubed, so it's going to be uphill. So we go like this. So it's going to be this shape of graph. So that's the first thing that we should be looking at. Pudding calculator. Yeah. It's paper 2, not paper 4 question. What do we look for next? Equate each to 0, find x roots. Yes. Again, try and systematize this. So first, next thing would be y-intercept. This will be the next thing I do, and that means set x to 0. If x is equal to 0, using the f notation, which is fine. So 0, 2, minus 3. Remember, anything times by 0 is just 0. So we know it's going to go through 0, 0, just like the example we did before. And yes, now we've got the roots. Now we can talk about the roots here. So the roots, called lots of different things. Roots, x-intercepts, solutions. There's another word I've forgotten. So we had x plus 2, x minus 3 is equal to 0. So either x is equal to 0, x is equal to minus 2 or x is equal to positive 3. So we know it goes through minus 2, so minus 2 here. We'll put 3 over here. And now we've got everything that we need in order to draw this function. Yeah, next x-intercepts, well done. Hello, Mohammed. So we go up through the function. Now notice we always cross the axes. We don't just touch them. And there's a reason for that, which I'll talk about in one of my A-level videos. And then we go up like this. So we've got our sketch here. If we wanted to, we could try and work out these maximum points. But for this question here, it's only a 3-mark question. They certainly will give you more marks to work with if they wanted those points. Notice that it's very clearly in the question here, show the values of the intersections with the axes. And that's what I've done. I've shown here, here, and here. If you look at the mark scheme here, so you'll see, so correct sketch without any labels. So the shape of the graph, we've got minus 2, 0, and 3 indicated. So here, here, and here. If you have the general shape of the graph, it goes through 0, 0. There's a maximum here, a minimum here, and again, just continues in both directions. So that's where we pick up the 3 marks here, using what we've talked about in this video. Because we have a given, true, because we've got a given domain, it doesn't keep going. This is true. Again, I'm usually taking it where it goes. That is a good point there. I will cross out my arrows because it just stops at minus 3 and 4. Yeah, that's true. Okay, welcome to another Ginger Mathematician video here, and we're going to go through everything to do with similarity. I've had a couple of requests for this kind of video. So let's get started on this part D, and we're going to combine some other topics in here, things like circle theorems and mensuration as well. So GKM, line on the circle, center O. FGH is a tangent to the circle at G. So notice this line that goes across just touches the circle and then goes off. And MG is parallel to OH. So that's why we've got these arrows here and here. And we need to show that triangle GKM, so it's worth identifying which triangle this is. So this one here. So GKM, so GKM, so those letters there, is mathematically similar to triangle OHG. So when you do a question like this, it's quite useful just to label the 2 triangles that we're focusing on. That makes it easier then to work out what is shared between the 2 triangles. Give a geometrical reason for each statement you make. So this is where this kind of question's a bit more like science, because you see there are 4 marks available for this. So we're going to need to put down 4 bits of information as we go along. So the first thing to notice here, and this is a circle theorem, again, if you're not sure about circle theorems here, then do check out the video above, is that if we take GOH, notice this angle here is a right angle. A tangent meets a radius of a circle at a right angle. And in a very similar way, if you take a diameter of the circle, then 2 lines that come out from the diameter also meet at a right angle as well. So notice they've integrated some circle theorems into this. What this means then is that angle GMK, now how do I know to use this notation? GMK, so M is where the angle is, and then G and K are the points surrounding it. Okay, and we're going to get lots of practice on this. And then we look at OGH. Notice G is where the angle is, O and H are surrounding. And if you're thinking, well, why not put down HGO? Well, that's also absolutely fine too. So these 2 angles are the same and both equal to 90 degrees. And we need to write some reasons. So tangent meets radius at 90 degrees. And then the other reason here, the diameter. So lines from diameter. Again, not much room to put all this in, but it's important. From diameter meet circumference at 90 degrees. I'll show you the mark scheme afterwards to see, you can make this a little bit shorter in terms of the information. So we have those 2 angles that are shared, which is very, very important. Now what we're going to do is show that 2 other angles are the same. And the angles I'm going to pick on here are this one here. So this angle here, so this is GOH. I'm going to show this is equal to this angle down here. So that's KGM. And the reason they're equal is another angle fact you need to know. Again, a very useful angle fact that comes up a lot. So if I do this now with my two triangles, notice there is what's called informally a Z angle. And so we need to give the proper reason for this. We need to use the right language here. And the reason is that alternate, so the Z angle is known as alternate angles are equal. So it's really important you put these very clear reasons down as you go. So if two angles are the same, then it stands to reason, if we look at the very last angle that we haven't considered here, these two must also be the same as well. So GKM is equal to OHG. Now, there's a couple of reasons you can put for this. You can say third angle in triangle. That is absolutely fine. But hopefully, some of you have spotted out there, this is also the alternate segment theorem. So this angle here must be the same as this angle here for the alternate segment theorem. Again, I really encourage you to check out my circle theorem video if you're not sure about that particular idea. And because then the three angles are the same, so all three angles the same, you can write down AAA as well if you so wish, are the same, then they are similar triangles. So they are similar triangles. So we've got all the information there for the 4 marks. Let me break that down. So the first part is showing they're 90 due to those two circle theorems, 1 mark. Then alternate angles are equal, therefore that's 2nd mark. The third angle in the triangle, therefore they're equal, and therefore some context sentence at the end saying, because all 3 angles are the same, the 2 triangles must be similar. And you can read through the mark scheme very, very carefully. You can see where I've picked up all those 4 different marks. Again, we had some alternatives here about not using alternate segment, just using the idea it's the third angle in the triangle. That is also fine as well. Okay, and on to a more classical kind of question here, so question 11. Again, whenever it's a similarity kind of question here, they are going to write down that phrase. They're going to write down mathematically similar. So that's a great trigger word to use to go, I need to remember this video that you're currently watching on similarity. And what we need to do here is calculate the side QR. So again, it's always good to know exactly what side we're looking for. As soon as I see a similarity question like this, I'm thinking scale factor. Now, what do I mean by the scale factor? Well, the way that I would work this out is I take 2 corresponding sides of the shape. Now, what do I mean by corresponding sides? Well, the same side in both shapes. So AB here and PQ, like so. Again, they're both the bottom side of the shape, so they're corresponding to each other. And then I take one and divide it by the other. So 8 divided by 6. Now you could do it the other way around as well. I'm going to stick with big divided by small. Now if I do that, again, we're just going to divide both by 2 and we get 4 over 3. You don't need to rush to a calculator with this kind of question. Try and be happy to leave it as a fraction. Now what we need to do here is work out RQ, so QR, so that's what we're looking for. And notice we're going from big to small. So this is the big triangle, this is the small triangle. So if I'm going this direction, I want to be dividing by that scale factor because I want to go from big to small. If I was going the other way, it would be multiplying. So all we're going to do is take the corresponding side to RQ in this shape, which is BC here, so therefore 6. And all we're going to do is we're just going to do 6 divided by 4 over 3. Now, of course, you can use your calculator for this. That is not a problem at all. I'm going to do some keep it, switch it, flip it, because that's good fun. So keep this, switch this to a times, and then flip the fraction. Again, that is also absolutely fine too. And if I work this out, this is 18 over 4. Again, use your calculator. It's a calculator question. And that's going to lead to my final answer here of 4.5. If you're wondering where that comes from, well, 18 divided by 4. You can always use the bus stop method. That's always good fun. And we get 4 there, carry the 2, 4's into 20, go 5. Again, like using non-calculator methods, but of course you can just use a calculator. at that point. And a very normal follow-up question to this is they'll do something to do with prisms here, so mathematically similar prisms. And the way I read this question is the volume, so that's really important here, of the larger prism is 320. We want the volume of the smaller prism. So as soon as I think of volume, I'm going to be thinking of volume scale factor. Now you're probably thinking, well, how do I work out volume scale factor? I just have the scale factor, 4 over 3, from the previous question. Well, all we do is we take that 4 over 3 and we're going to cube that number. Okay, because notice we've got centimeters cubed, or cubic centimeters. So we want to take that and then cube it. Now again, we can use a calculator here, but if I cube this, we're going to get the same as 64 over 27. 4 cubed, 64. 3 cubed is 27. Now we're going to do the same logic here. We are looking for the smaller prism, so we're going from big to small. So we're going to divide by this new scale factor. So to work out the new volume of small, just to remind me what I'm doing here, I'm going to do 320 divided by 64 over 27 cubic centimeters for the 2 marks. Again, you can check the mark scheme here. Again, you get a method mark for cubing that scale factor. Again, either way round. Notice I used 8 over 6, but you could also do the same process with 6 over 8, as long as you're times you're multiplying correctly too. Okay, and on to the next question here. Again, very similar kind of questions. This is why you watch these videos, to really see the patterns between the questions that come up. And in triangle PQR, so that's the whole triangle, so that's the whole triangle that goes around the outside. Again, M lies on QR and S lies on PR. Okay, probably don't need to put the ink there. Explain giving reasons why triangle PMR. So let's identify that. Okay, well, we've got this. This is our PMR. Oh, a little bit on the wobbly side. It's fine. Saved it. There we are. Is similar to triangle MSR. Okay, so that's the smaller triangle inside. And we need to find out why they are similar. Okay. You can't just put they're contained within each other. That doesn't work. Right, so PMR is equal to MSR. Right, so notice that this is a right angle here. It's on the same straight line. And we've got a right angle here as well. So they share this right angle. So we need to write this in nice and carefully. So PMR is equal to MSR. And they're both equal to 90 degrees. Again, I think that's quite clear why that's the case. I don't think we need to write any more reasons on that. The next thing to realize is they share an angle. So notice that this angle is the same in both triangles. So again, we need to identify this carefully. So angle PRM is equal to SRM. So shared angle. So that's my second piece of information. Okay, so we've got 2 angles. Now, I think that makes it actually quite easy now, because the last angle that we haven't mentioned yet, where did my pen go? My pen decided to disappear. There we are. So, if this angle is the same in both, we've got a right angle that's shared. That must mean the last angle we haven't talked about, so this one and this one. So, MPS must be equal to SMR. Don't worry, won't do any SMR videos here. And that's because it's the third angle in the triangle. You know, 2 are the same, and the other one must be the same as well. So they add up to 180. So therefore, and we can write down AAA, or all 3 angles. So that means the triangles are similar. You don't need to overcomplicate these questions. As long as you find 2 angles, then you can find the third angle is going to be the same, and therefore the 2 triangles here will be similar. So we'll go through part B and then we'll come up. You can just see the answers quickly here. So you can see putting AAA gives you that third mark, which is important. So let's get started on question 1 here, where we need to simplify the following expression. Now, the first thing that I notice here is notice there is a common factor of x in the numerator. So when I'm copying this across, I'm going to take a factor of x out here, and then I'm going to work backwards. So what do I multiply x by to get 5x? A 5. What do I multiply an x by to get minus x squared? That's going to be a minus x. Now, usually in these algebraic fraction questions, there will be a factor that looks like this in the denominator, so I can cancel through. So that's kind of my little cheat method here. I'm looking out for a 5 minus x down below. Now, if we take the 25 minus x squared, this is a very special form of factorizing, known as dots, D-O-T-S, the difference of two squares. Difference because we have a negative here, and squares because we have a square number here and a square number here. Now, this is a special number, 25. If we find the square root of 25, that is equal to 5. And of course, the square root of x squared will then just be x. So I'm going to use these here, and I can write this now in a special factorized form. Taking these numbers, 5 and x, I write here a 5 minus x and a 5 plus x. Now, if I'm not sure that that's actually going to work, one thing I can do here is expand my brackets to check if it's correct. 5 times 5 is 25. 5 times x is plus 5x. Minus x times 5 is minus 5x. Minus x times plus x is plus x squared. And you may be thinking here, well, that's not the same as denominator. It's quite different. Notice there's a cancellation. We have a plus 5x here and minus 5x here. That then gives us cancels. This should be a minus, by the way. Well spotted if you notice that, because minus x times plus x is minus x squared. Notice that leaves us with 25 minus x squared. So we do get the denominator. Now, why do we actually factorize these things in the first place? Well, notice we have a 5 minus x in the numerator, 5 minus x in the denominator. We can cancel those out, giving us x over 5 plus x as our final answer. I can pop that in here. Now, if you're finding this quite tricky at this point, don't worry, we're going to do a ton of different examples so you're up to speed on this tricky topic. There's the mark scheme and where you pick up the method marks over here. And on to question 2. In this case, we need to write as a single fraction in its simplest form. So the first thing to notice here, we have different denominators. We have an x minus 5 and we have a 2x. So one way to make one fraction here is to multiply the two denominators together. So if we do that, we just get x minus 5 times 2x. Notice in algebra, if we're multiplying, we just put the two things next to each other. Now, how do we work out what goes in the numerator? We essentially do an idea of cross multiplying. So we do a 2x times 3 here and an x minus 5 times minus 7. Notice sometimes it's called the butterfly method, okay, this idea of multiplying crossways to work out what goes in the numerator. So we have a 3 times 2x, that gives us 6x, and then we have a minus 7, be very careful, there's a minus here, times x minus 5. Once we've got this, we just now need to tidy it up. So how do we do this? We keep the denominator the same. I'm just going to switch this over, it looks a bit more neat. So 2x brackets x minus 5. And at this point, we have 6x, we'll leave alone for the time being. We have a single bracket, which we multiply using the hook. That's what I like to call it here. So we get minus 7 times x is minus 7x. Minus 7 times minus 5. Be careful here. That's equal to plus 35. And now if we simplify this, we get 6x minus 7x So I have 6 bananas, and then 7 bananas disappear, minus 1 banana. And then we have plus 35 over 2x brackets x minus 5. Notice I didn't expand at the bottom here. You could and would still get all the marks, but I prefer to leave it in this factorized form because it is its simplest form essentially, and leave it like this to get me all 3 marks. Again, notice in the mark scheme, you can also put it the other way round. Again, this is maybe a little bit more tidy. Notice minus x plus 35 is exactly the same thing. On to question 3 here. So again, we want to simplify. We're going to go through a very similar method to what we did in question 1. I look at the top of my fraction and go, what do they have in common? So notice there's an x in common. And then let's look at the numbers. So what number goes into 4 and 16? That's going to be 4. And now we work backwards. So what do I multiply 4x by to get 4x squared? That's going to be equal to x. What do I multiply 4x by to get minus 16x? It's going to be minus 4. And just like in the previous question, number 1, I'm expecting an x minus 4 in the denominator because we need to have some cancellation going on. Now notice we have another difference of 2 squares here with x squared minus 16, because remember the square root of 16, so something times something gives you 16, and it's the same. What is it? That's 4, and the square root of x squared is just x. So we can factorize it in that very, very special form that we've seen before, where we have an x minus 4 and an x plus 4. We achieve what we're looking for here. Notice we have an x minus 4 above and below. We can cancel those out, giving us 4x over x plus 4. And that is our final answer for a whopping 3 marks, just for that fairly short process. There's the mark scheme here, and you can see where you pick up the method marks. On to question 4 here. This is slightly different. Again, lots of marks available here, 5 marks, and we need to solve the equation now. However, we do start it out like we did with question 2. So in question 2, we found a common denominator, and the best way of doing that is just multiplying the 2 denominators together. So I can just write them next to each other, x plus 1 times x plus 9. The way that we work out the numerator, we do this cross-multiplying method here. So that gives us 1 times x plus 9 is just x plus 9. 9 times x plus 1, okay, 9 lots of x plus 1. And that's equal to 1 here. Let's tidy up that numerator. So if we look at the numerator here, we still got the x plus 9. Let me pop in the bottom bit here. So we have x plus 9, and then we have 9 times x is 9x. 9 times 1, that's equal to 9, and this is equal to 1. So we've kind of done the method in question 2. That's about 2 or 3 marks worth. Now we actually have to solve this thing. Now, first thing is, I do not like fractions here. This fraction is irritating me. So what's the opposite of dividing by x plus 1 times x plus 9? Let's multiply by x plus 1, x plus 9 on both sides. Quite hard to write all this out. This cancels, giving us the numerator. We can simplify that at the same time. So we get 9x plus x, that's equal to 10x. 9 plus 9 is equal to 18. And this is equal to 1 times this. So it's just going to be x plus 1 times x plus 9. We've still got work to do here. So first of all, we need to expand out the bracket. So remember, our first, outside, inside, last, or I prefer to call it the double hook. Give it a big double hook. So if we work out the right-hand side here, we have x times x is x squared. X times 9, 9x. 1 times x is just x. and 1 times 9 is 9. We are making progress, I assure you. So let's continue this up here. So I'm going to tidy up the right-hand side. So that's x squared plus 10x plus 9 is equal to 10x plus 18. Notice I've also switched the sides, but that's absolutely fine because we have an equal sign in the middle, so I can swap the sides. That isn't a problem. Now let's get rid of the 10x. So the opposite of adding 10x is minusing 10x from both sides. Get a nice massive cancellation here. So this and this disappear, giving us x squared plus 9. This cancels with this, giving us 18. We're almost there. Keep with it. So we've got an add 9 here. So the opposite of that is minus 9. So this cancels, leaving us x squared. 18 minus 9 is equal to 9. And then final step here, we're almost there. What's the opposite of squaring something? We're going to square root on both sides. That leaves us with x on its own, the square root of 9. This is where we have to be very, very, very careful. Notice there are two answers it's looking for. So it's not just 3, but it can also be minus 3 as well. Why is that the case? Well, minus 3 times minus 3. Minus times a minus is a plus, and 3 times 3 is 9. So whenever we're square rooting, there are two possible answers to consider. So our very final answer here is x is equal to 3 and x is equal to minus 3, like so. Again, you can have a look through the mark scheme and see where we pick up all these method marks. And if this video has been really, really helpful to you so far, then do think about liking and subscribing. That's the best way to keep up with all the different iGCSE content that is coming out. And I'm going to talk to you about the sponsor of this video, which is me, with my predicted papers. So these predicted papers are built by ourselves here, making sure we're using that 12 plus years of experience that I have as an iGCSE maths teacher to give you the very best authentic experience for that iGCSE maths paper 2 that's coming up in May 2025. So if you want to check that out, again, go to my website, Predicted Papers. The link will also be in the description. Okay, welcome to another Ginger Mathematician video where I'm going to go through the exact trigonometry values that you need to succeed at iGCSE Paper 2, but also very useful for IB learners as well. If you like the content I'm doing, then please do think about liking and subscribing. Right, let's get started. So you should know, first of all, sine 0, cos 0 and tan 0. These are worth learning off by heart, and you'll see them just there on the screen there. But now let's work out these things like sine 30 or cos 45 and how to know those off by heart. And the way I like to do this is by using two very special triangles. So my first triangle I'm going to draw over here. So this is a right angle triangle, weird kind of angle there, but there we are. And then we have a right angle here, and I'm going to make this side 1 and this side 1 as well. Now, if I know these two sides, I can work out the hypotenuse here by using a bit of Trig, a bit of Pythagoras. So remember that x squared is equal to, well, 1 squared plus 1 squared. So using Pythagoras, that means then that x squared is equal to, well, 1 squared is 1, 1 squared is 1, 1 plus 1 is equal to 2. So therefore x, the hypotenuse here, well, I square root both sides, and that gives me the square root of 2. So this is how I know this is the square root of 2. And because this is 1 and this is 1, this is an isosceles triangle, which means that this angle and this angle have to be the same. Well, if this is 90, triangles add up to 180. So these two have to add up to 90. So each one is equal to 45 degrees. And in my mind, I know this triangle off by heart. And by knowing this triangle off by heart, I can work out the following calculations. So I can work out what sine 45 is, I can work out what cosine 45 is, and finally, I can work out tangent of 45 as well, just by using my normal SOHCAHTOA. So remember, sine 45 is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and then tangent is equal to opposite over adjacent. So what I'm going to do is label my triangle. Well, let's just take this angle down the bottom here. So this will be O, the opposite, this is A, and then this could be my hypotenuse H. And now I substitute into my normal SOHCAHTOA. So opposite is equal to 1, hypotenuse is equal to root 2. So sine 45 is equal to 1 over root 2. This is something that you'll need to learn, or learn these special triangles. Likewise, cosine 45 is equal to adjacent, well that's 1, divided by, well, the hypotenuse is equal to root 2. So cos 45 and sine 45 are the same, which is useful to know. And then tan 45, well, that's equal to opposite, which is 1, divided by adjacent is equal to 1, so that's equal to 1. So the key values to know here, get the old highlighter out here. So sine 45 is equal to 1 over root 2, cosine 45 is equal to 1 over root 2 as well, and then tan 45 is equal to just 1. So those are the 3 out of the 9 values that you need to know off by heart. Now my second triangle is a little bit different, so I'm going to start with a triangle that doesn't look like this. Try not to use the highlighter when we're actually trying to use the pen. There we go. So I'm going to draw a triangle that looks like this. I'm going to make each side 2, not 1, and I'm going to show you why a bit later on. The next thing I'm going to do here is, well, angles in equilateral triangle are all the same. So this angle is going to be 60, this angle will be 60, and the total angle at the top would also be 60. Now what I'm going to do is what's called drop a perpendicular, drop it straight down here. So we go, here is our right angle, and because this bisects the angle, splits into 2 equal parts, this will be 30, and this will be 30 as well. And because it splits it into 2 equal parts, it means that this length here, this is why we made this 2 in the first place, will be equal to 1. Now what I'm going to do is I'm going to zoom in on that right hand triangle. So I'm going to zoom in to this part here and do it over on the side. So if I draw this now a bit more clearly in red, this is equal to 1, this is equal to 2, this is 60, and this is 30. And by using Pythagoras in a very similar way to in the first triangle, we can work out the missing value. So x squared here is going to be equal to 2 squared minus 1 squared, because we're looking for a smaller side. And so x squared is equal to, well, 4 minus 1, which is equal to 3. And if we square root both sides, we then work out that this missing side is equal to the square root of 3. And now I'm ready to work out these 6 missing values. So let's do this in blue. And we'll start with 60. So we'll do sine 60, cos 60, and then tan 60, like so. Again, we need to label those sides. So this is going to be our opposite the angle. This is our adjacent, so next to the angle, and this is the hypotenuse. Again, we use the same formulae as we did before. So sine is equal to opposite over hypotenuse. I'm waiting for someone in the comments to write, oh, he wrote O over A. There we are. So cosine is equal to A over H, and then tan is equal to O over A. Again, we do this in a similar way. So sine 60 is equal to opposite, which is root 3, divided by 2. So that's our first one. Cosine 60 is equal to A, which is 1, over a hypotenuse, which is 2. So cosine of 60 is equal to a half. And then tan 60 is equal to O over A. So opposite is root 3, adjacent is 1, and that's just equal to root 3. So those are our first 3 exact values from this triangle. Sine 60 is root 3 over 2, cosine 60 is equal to a half, and then tan 60 is equal to root 3. Now what we're going to do is focus on the 30 angle here. So
notice because I'm focusing on this angle, these two are going to swap. So my new opposite is going to be opposite the 30 angle, which is O, and then the adjacent side will now be this root 3. So things are going to be changing around. From here, I can now work out sine 30, cos 30, and tan 30 as well, in the same formula as over here. So sine 30 is equal to opposite, which is 1, divided by the hypotenuse, which is 2. So sine 30 is a half. Cos 30, well, that's equal to adjacent, which is root 3, divided by 2. That's that one. And then tan 30, that's equal to opposite, which is 1, divided by the adjacent, which is root 3. And that gives me my last exact value. So sine 30 is a half, cos 30 is root 3 over 2, and lastly tan 30 is equal to 1 over root 3. So the 9 angles underlined: sine 30, cos 30, tan 30, sine 60, cos 60, tan 60, and then finally sine 45, tan 45, and cos 45. These are exact values you need to know for the non-calculator paper. I had a request to do a video like this, so hopefully you enjoyed this video and now know how to work out these exact values really, really quickly.
Question 15. This is a paper 2 question here. So y is proportional to, remember this weird fish symbol means is proportional to. So that's important to remember for many of these questions here. And we're told some what we call initial conditions. So when x is equal to 4, y is equal to 3, and then find y in terms of x. So first thing we're going to do is take our proportionality statement, so with the weird fish symbol in there, and then we're going to change that into an equation. So the way we do this is we still leave y exactly where it is. We change this to an equals, and where we'd have a 1 at the top here, we change that to a k. Again, if you want more detail on exactly this process, then do check out the video above as well. And at this point, we then just substitute these values in. This helps us work out what k is going to be. So I'm going to make it nice and clear to the examiner. When x is equal to 4, y is equal to 3. Let's pop those in. So wherever I see a y, I'm going to put a 3. The k is what we're trying to find. And then we have the square root of 4. And now this is just a case of tidying up here. So remember, the square root of 4 is equal to 2. And then we want the k on its own. So what's the opposite of dividing by 2? Well, we want to times by 2 on both sides. 3 times 2 is equal to 6, and that gives us the value of k that we're looking for. Now, we haven't finished the question at this point. That's really important. We now need to write y in terms of x. That's the actual question. So I'm going to take this equation here, so our basic equation, and now I'm going to replace, let's get the old trusty highlighter out here. I'm going to replace that k with the answer of 6 that we got earlier. So all we're going to do to write the full answer here is y is equal to 6 over root x. And that's really important because many people just stop at this point and go, I've got the constant, it's great, I can move on. But you need to write the answer correctly to make sure you get all 2 marks here. So you can see the mark scheme, and again you pick up a method mark for writing that equation that I did at the start of the question. Okay, on to question 3 here. So y is directly proportional, so that's important, to this kind of like a weird expression here, x plus 1 all cubed. And this is what they're doing with these kind of variation proportion questions. As students are getting better and better at them, they are trying to put a few little twists and turns. Now, we're given some initial conditions, which we'll come back to in a moment. And we need to find the value of y when x is 4. Now, the process I'm going to do here, I'm going to do quite a lot in this video. So even if you're not sure about what I'm doing in this question, you're going to see this process again and again. So the first thing we need to do here is write a proportionality statement. What does that actually mean? Well, we get y is directly proportional to, so proportional to, x plus 1 all cubed. So I've translated that first sentence here. Y is directly proportional to x plus 1 all cubed. and I've written it as a proportionality statement. Now I'm going to do a similar thing to what I did in the previous question. I'm going to turn this into an equation. So I get y is equal to, now this is slightly different to the fraction. We put the k in front of the term here. So we go k x plus 1 all cubed. Again, you're going to see lots of questions like this, so just stick with it and we'll get lots of practice. Now, once we've written our equation, we substitute those values in, just like we did before. So when y is equal to 32, x is equal to 3, and now we just replace the y and x. So y is equal to 32 here, k is what we're looking for. Now x we know, x is equal to 3, 3 plus 1 all cubed. And now it's a case of just working out the equation like we did before. So 32 is equal to k. Remember, if there's nothing between the k and the bracket, it means a multiply. So 3 plus 1 here is 4. That means then that 32 is equal to, well, 4 cubed is 4 times 4 times 4, which gives you 64. Again, you can reverse these around as well. And then we want to get the k on its own. So the opposite of timesing by 64 here is dividing by 64 on both sides. This gives us then 32 over 64 is equal to k. If we simplify this down, then that means that k is equal to a half. So again, we haven't finished the question. It's a 3-mark question now, not a 2-mark. So there's going to be a little bit extra that we need to do. So we're going to take our initial equation, just like we did in the previous question. So when I say that, I mean this part here. And we're going to replace that k here with what we've just worked out. So a half. So we're going to write this in. Y equals a half x plus 1 all cubed. And now we need to find the value of y when x is equal to 4. So when x is equal to 4, then that means that y here is equal to 1 half 4 plus 1 all cubed. A lot of calculation work here in these kind of questions. So you get a half times 5 cubed this time. So essentially you want a half of 5 cubed, which is 125 divided by 2. I'd be happy with that answer and leaving it like this. You'll see in the mark scheme they actually do divide through by 2, and it's also equal to 64.5. 62.5 even. That's better. For the actual answer you're looking for. So actually cross that out, 62.5. There we are, nice and clear. And now, as you see in the mark scheme a bit later on, they put this OE, which means or equivalent. So you can write it as a fraction. You can also write it as a decimal. Now, part B is a typical follow-up question to this. So now we want to take this equation that we worked out in part A and find the value of x when y is 13.5. So I'm going to replace the y with 13.5 and leave everything else the same. So we get 13.5 is equal to a half x plus 1 all cubed. And again, this is just a slow process of breaking this down. So let's get rid of the half first of all. So what's the opposite of timesing by a half? Well, actually timesing by 2, because that would cancel. So 13.5 times 2, that's equal to 27. This cancels. That was the whole reason to do that there, giving us x plus 1 all cubed. And when you start getting numbers that are working and nice, this is generally a good sign in a question like this. So what's the opposite of cubing? Well, we want to cube root both sides. And notice the cube root on the left-hand side, the cube root is 27, is a number that we can actually just work out in our head. So something times something times something gives you 27. What is that something? Well, that's going to be 3. So we get 3 is equal to x plus 1. Probably the easiest equation in the world at this point, and I'm sure we can all see at home that x is equal to 2. But this is the paper 4 question, so we're not quite finished. We've still got to do a little bit of rearranging. So what we now need to do is a skill that you see in other questions, particularly my functions video that I went through. So you want to check that out, then please do look at the video above And we're going to do basically that process there. So we need to find x in terms of y. So we take our equation. So y is equal to a half x plus 1 all cubed. And this basically means we want to write at the end x equals something. That's what the question is actually asking you to do. Now, the way I tend to approach this is, first of all, flip the equation. So I have the x on the left-hand side where I want it. And then we just work through the process, very similar to what we did in part B. So the opposite of timesing by a half is timesing by 2 on both sides. This cancels. That leaves us then with x plus 1 all cubed is equal to 2y. Now, we're trying to break this down to get x equals. This cubed is kind of annoying. So what's the opposite of cubing? Well, cube root. So we're going to cube root on both sides. You just take your time, making sure being nice and careful with the algebra. So we're left with x plus 1. Now we get the cube root of 2y. And then lastly, we get, we need to minus 1 from both sides. The opposite of plus 1 is minus 1 on both sides, giving us our final answer, because this cancels here, of the cube root of 2y, then minus 1. And then we just need to write this nice and clearly again for the examiner. One thing to notice here, so if I show you the mark scheme, notice, be very careful with the square root here. It doesn't go over the entire expression, it's just that first part. So notice how I've written this here. I have to be really, really careful to make sure the minus 1 doesn't sneak in under that square root. So keep that in mind. Okay, you can see the mark scheme. Again, this is a pretty hefty question, it's 8 marks. If it comes up in your paper 4, then it's something that you really want to make sure you get all those 8 marks in as well. Okay, so now let's look at some specimen paper questions. So these have been specially prepared by Cambridge to get you used to the 2025 course. So first question here, we need to simplify this addition. We've seen a question just like this already. So the key thing to do here is we need to simplify these surds. Let's start with the smaller number, so root 32. Notice we can write that as root 16 times 2. So the biggest number that fits in, which is a square number. Again, I can use that to help me with this number, because I know there needs to be a times 2. So I need to think, okay, if I divide 98 by 2, get 4, carry the 1, 2's into 18 go 9. Aha, another square number, in this case 49. Again, use the first part to help you with the second part. Then we simplify this, so root 16 is equal to 4, so we get 4 root 2. Square root of 49 is equal to 7, so we get 7 root 2. 4 root 2 plus 7 root 2, that gives us 11 root 2. Again, think of this like 4a plus 7a is equal to 11a. So we get 11 root 2 for our 2 marks. Here we've seen a very similar example already, earlier part in the video. So we have 1 over root 2 plus 1. We need to multiply by its conjugate. Again, what does that mean? We multiply by root 2 minus 1, top and bottom here. Again, you can always think of this like brackets. If we multiply the top, well, 1 times root 2 minus 1, that's just going to remain as root 2 minus 1. Multiplying by 1 doesn't change what it is. Now we use first, outside, inside, last. So root 2 times root 2 is 2. Root 2 times minus 1 is minus root 2. 1 times root 2 is plus root 2. And then 1 times minus 1, careful, is equal to minus 1. We get this nice simplification in the middle, leaving us with root 2 minus 1 over 2 minus 1, that's 1, which we could just then write as root 2 minus 1 to give us all 2 marks on this question. Then you can see the mark scheme. You get a method mark for knowing about conjugates, and then 1 for the answer. If you put root 2 minus 1 over 1, that would probably get the 2 marks as well. And notice 11 root 2 for 19a. On to our second question here. Almost identical, but this time we have a negative instead. Still approach it in exactly the same way. Notice root 3 can't really be simplified here, but we can simplify the root 75. Notice we already have a 3 here, so I am thinking to myself, what do I multiply 3 by to get to 75? Aha, a square number, 25. So we can simplify the first third here. Root 25 is equal to 5. So we get 5 root 3 minus root 3. Just be careful at this point. This is the same as doing 5a minus a, which would then give us 4a. So 5 root 3 minus 1 root 3 essentially is equal to 4 root 3. One of the biggest mistakes that's made on this kind of question is you forget to subtract and you add instead and put 6 root 3. Please don't do that in the exam. The next part, again, we approach this in the same way as before. So we have 8 over 1 minus root 5. We multiply by its conjugate, so it's positive version here. So 1 plus root 5. Even though the surd and the number are the other way round, still approach it in the same way. So let's work our way through this. The top here is a single bracket. So 8 times 1 is 8. 8 times root 5 is 8 root 5. And then we do the bottom with first, outside, inside, last. So 1 times 1 is 1. 1 times plus root 5 is plus root 5. Minus root 5 times 1 is minus root 5. And then be careful here, minus root 5 plus times plus root 5. That gives us negative 5. So be careful with that. Then if we continue, we get 8 plus 8 root 5. We have the cancellation in the middle. That gives us then 1 minus 5 is minus 4. And we're not finished at this point. You have to look out for cancellation here. Notice 4 goes into this number, and this number. If that's the case, you have to simplify through. So how many 4s go into 4? 1 time. How many 4s go into 8? 2 times. How many 4s go into 8? 2 times. So we get 2 plus 2 root 5 over minus 1. Notice that looks a little bit ugly here. So what we can do is then just put the minus through. So we get minus 2 root 5. And that will be our final answer for a fairly tricky 3 marks here. Again, you can look at the mark scheme here. Notice you could also factorize this as well and put it back in. That's absolutely fine as well. Again, both answers will give you all 3 marks. And again, we've got 4 root 3. Notice correct answer only. Again, if you don't get 4 root 3, then you won't get all 2 marks here. If you want some more practice on surds, then I do suggest you check out the video right in front of you. Even though this is more for the 0607 course, it's very, very good practice for 0580 as well. So if you're not sure about some of the concepts we've gone through in this particular video, do use that video to catch up on them. Right, let's move on to another very classical functions question for iGCSE. If you're liking the content as well, then please think about liking the video. Right, so this time we've got another composite function, but notice we have a number involved. So this makes our life a little bit easier. The first thing we're going to do is work out f of 7. So we're going to work out what's inside this bracket. So f of 7, so that means wherever we see an x in the f function, we're going to replace it with a 7. So we get 7 squared minus 7 minus 30. Again, this is a calculator question, but again, I'm going to work it out without. So 7 squared is 49, minus 7, minus 30. And then if we work that out, that's going to give us the answer of 12. Now, this is the key point at this bit here. So we've worked out that this is equal to 12. So all we're going to do at this point is replace that with a 12. So we're going to work out h of 12. So h of 12, wherever I see an x in here, I'm going to change it to a 12. So we get 2 lots of 12 plus 7. So that's equal to 2 times 12 is 24. 24 plus 7 gives us our final answer here of 31. And notice the inverse function has come up again. So this here, as soon as you see that minus 1, You know it's going to be an inverse. And now we're going to use that three-step procedure that we saw on the previous question here. So question III. So hopefully you remember it at home, what we've literally just done. So number one, we're going to take our function and make it equal to y. So y is equal to 2x plus 7. Number two, we're going to flip over the y's and the x's. So we get x is equal to 2y plus 7. And remember that third step, give yourself 5 seconds to think about it. What was that step? That's it. We're going to make y the subject. So as soon as you see this inverse process, it's always the same calculation that we go through. So first of all, I'm going to flip it. So I have the y's on the left-hand side. And now I need to get y on its own. So we go through this two-step procedure. What's the opposite of adding 7? Well, we need to minus 7 from both sides. This cancels, so we're left with 2y is equal to x minus 7. And then we want to get the y on its own. So what's the opposite of timing by 2? Yeah, we're going to divide by 2 on both sides of the equation. This cancelling, and we're left with our final answer of x minus 7 divided by 2. Remember, this y equals whatever's on the right-hand side, right at the end, is going to be our answer. So this x minus 7 divided by 2, like so. And if you're aiming for, say, a C grade or even a B grade, you need to make sure you're getting these first two questions correct almost 100% of the time. So you've got that in the bag. So when we go into harder questions, then you've already got that grade secure on these questions. Now the next one is g of h of x. This is what we call a composite function. So keep writing these keywords down, and notice it says simplest factorized form, which we'll come to right at the end of this question. Now first of all, what is h of x? Well, it's equal to 2x plus 7. So I'm going to copy out this, and wherever I see an h of x, I'm going to put a 2x plus 7. Now once I know that, I'm going to look now at my g function. So this is my g function here. And wherever I see an x in my g function, I'm going to replace it with a 2x plus 7. So it's a bit of a trickier question compared to what we did last time. So if I copy this out, I get 2x plus 7 all squared minus 36. And so now we've got a bit of algebra to do to expand everything out and simplify. So remember, if you've got a bracket squared, so 2x plus 7 all squared, this is the same as saying 2x plus 7 multiplied by itself. And as soon as you've got double brackets, you know what's coming. We're going to use FOIL. So remember, FOIL is first, outside, inside, last. So you have to make sure you follow this very logical procedure. So let's do this. So 2x times 2x, that's equal to 4x squared. 2x times 7 is equal to 14x. 2x times 7 in the middle is equal to 14x as well. And then finally 7 times 7, that's equal to 49. And before I copy this across to down here, let's just collect the like terms. So we have 4x squared, we leave that alone. 14x plus 14x is 28x. And then we have the 49 as well. So I'm now going to copy that across to our calculation. So we get 4x squared plus 28x plus 49. And don't forget the minus 36. So let's just simplify this down. So we have 4x squared plus 28x, and 49 minus 36 is plus 13. Now many students out there think they've got the final answer. They start celebrating, but remember what I underlined earlier. It's simplest factorized form. And as soon as you see factorized, that's a mathematical word to put into brackets. So we need to think how we're going to put this into brackets. Well, because we've got a quadratic here with all the three terms, it's going to go into double brackets. And now we have to think about what's going to go inside them. Well, 4x squared, well, that can be 2x times 2x. You could also do 4x times x as well, but we'll start with this one first and see what we can work out. So remember, to work out these numbers here, we need two numbers that multiply to give us 13. Now there's not many options here because 13 is a prime number. So we have either 1 and 13. We could also have minus 1 and minus 13, but notice this is a positive number, so it can't be minus 1 and minus 13. So that leaves us with only one option here, which is 1 and 13. So let's pop that in. And what I'd always do in the exam is check that we do get the middle term here by checking the cross terms. Now what do I mean by the cross terms? Well, I mean when we multiply the outside here and the inside, because that gives us our x term in the middle. So let's just double check this. Well, 13 times 2x is equal to 26x. 1 times 2x is equal to 2x. 26x plus 2x is equal to 28x, which is exactly what I want in the middle. So that's going to be our third mark, making sure we can put this into double brackets. So that's pretty tricky to notice that, first of all, you need to do that process, and then secondly, that this difficult factorization is actually possible here. Okay, let's move on. So now we're going to have to simplify f of x divided by g of x. So let's just remind ourselves what those functions are. So we have x squared minus x minus 30 as our f function. And then our g function down below is x squared minus 36. So this is turning essentially into an algebra question, even though this is under functions. And what we want to do is simplify. So the first thing we see here is that we have quadratics in both. So we want to try and put them into brackets. And then we hope that something will simplify as we go through. Now if we look at the bottom one here, x squared minus 36, this is a special form of quadratic known as difference of two squares, or dots as I like to call it as well. And what this means is that both of these are square numbers. X squared is a square number and 36 is equal to 6 squared. And this has a very special factorization that you need to learn for the iGCSE course. And what this means is we can put this into brackets of x minus 6, x plus 6. Now if you don't believe that, you can always go through FOIL and check the expansion. The key thing here is that the plus 6x here and the minus 6x cancel, and this is why there is no middle term here. This is a factorization you need to recognize, particularly on paper 2 questions. This is actually a paper 4 question, but it's useful to do. Now you can be kind of sneaky with these questions because you know if it's anything going to simplify, you know there needs to be an x minus 6 or an x plus 6 up here, so we can cancel later on. Now we know there's an x at the start here, and what we need to do is factorize the top. So we need two numbers that multiply to give us minus 30, but add to give us minus 1. So that's what's going through my head here. Multiply to give me minus 30, but add to give me minus 1. So what I do here is write down all the number pairs that multiply to give me minus 30. Well, obviously got minus 1 and 30. We have minus 2 and 15. We can move the minuses around. So 1 and minus 30, 2 and minus 15, 3 and minus 10, and minus 10 and 3. And you're thinking, God, that's a lot of combinations here. Minus 6 and 5, 6 and minus 5 as well. But remember that second rule that I talked about here. So you also need to add to give me minus 1. If I look at these combination here, the only one that works here is this one here. Remember, minus 6 plus 5 gives me the negative 1. So even though there's lots of combinations, using that second rule that we're allowed to, because there's no number in front of the x squared, limits down those options. So we put in x minus 6 and x plus 5. And yes, we get exactly what we wanted here. We get the same bracket above and below. And if that happens, then we are allowed to cancel. So we can just cancel these through. And then we get our final answer for 4 marks of x plus 5 over x plus 6. So we can write that in like so. In 4 marks, there's a lot of work in here to do, recognising dots, factorising the top, realising you can cancel, and then getting to our final answer. But if you're looking for those higher grades, those AA star grades, these are questions you need to be getting all those 4 marks on. Right, so you can check the solutions that I've gone through here. A little bit sneaky at the end. They did it a slightly different way with the factorisation process, with the splitting the term, but again, as long as you have a method for it, that's absolutely fine.
Now, I was looking through the statistics behind the scenes on Ginger Mathematician, and I realised only 35% of you are subscribed to the channel. So there's a whopping 65% of you that are currently not subscribed. I'd appreciate it a ton if you could press that subscribe button. Again, the more subscribers that we have, again, the bigger content I can make. As you know, I've been spreading into A level. Paper 1 is pretty much finished now, but we've got paper 5, paper 3. So there's lots of more content to come out here, as well as up-to-date iGCSE content to make sure you know about the very latest trends that are going on.
Okay, let's continue. So we're on to question 9. This is one of the short answer questions that you get. So A, B, C, D, and E lie in a circle. Angle BCE is equal to 75. Already marked in our diagram. And find the value of P and the value of Q. Okay, so first of all, we don't have the centre of a circle, so no isosceles triangles. So my next thing to look at is the same segments. So if I take this angle here, 75, and go along the two sides until I reach a vertex, you'll notice I reach E and B over here. Let me just draw this in. Love these questions. You can just do lots of drawing, basically. Not quite like a geography exam. And then once we've found these two vertices, E and B, then we can just go along the edges that are available. So we go along here and along here. So we stay on the same segment. And notice that we actually get to angle P. So by doing this process, we can show actually P is equal to this angle here. So P is equal to 75 degrees. Perfect. And once we've realized that this is 75 degrees, we can use that other rule that I've talked about a lot already, the good old cyclic quads, making sure that each of the vertices of our four-sided shape are on the circumference. And let's just check this. So if I draw around this shape, it is worth repeating these ideas because, as you can see, these circle theorem questions, they come up a lot. Notice each vertex is on the circumference, so everything is good. And remember, the angle here, 75 plus Q equal 180. So Q is equal to 180 minus 75, which is equal to 115 degrees. So we can pop that in for our second mark. Right? Helps if I can actually do oh dear, of course that is equal to 105. That would be very, very true. So when you're in exam, make sure you can actually do some subtracting. Again, I think this is a non-calculator paper, if I remember rightly, from 0607. But this is, of course, equal to 105 degrees. Again, good rule for you at home. Please don't celebrate until you've got the answer and you've got it absolutely correct. Right, those are the answers for you. And let's move on. So now we're on to question 12. So A, B, C, D, and E are points on the circle. Angle CAD, good old computer-aided design, is equal to 35 degrees. Yep, that's marked in already. And angle EBD is equal to 15 degrees, which is already marked in as well. And now we need to find the following angles, CBD and CDE. So CBD, got B in the middle, CBD, so that's this angle here. And the way we find this is the same way that we've done the previous question. So first of all, I'm going to look at this. Again, no center of the circle again. We go along the edges until we hit a vertex, which in this case is going to be CD. And then we go along the lines from there until we hit an angle of some kind, which happens to be the one we're exactly looking for. So from this, we know then that this angle 35 is the same as this angle here, which is very, very useful. So let's pop that in. That's equal to 35 degrees. Once we've got that, then we need to look for angle CDE. This is where we have to be careful with which angle we're looking for here. Now we know it's a D, but there's a few angles it could be. So that's why we need to be careful. So C to D to E, that's going to be this entire angle here. So So this entire angle, the red angle, the obtuse angle, I've just highlighted. And again, this is very similar to the previous question here. Again, we've got a cyclic quad. There's a little twist on this question compared to what we looked at before. Again, I'm going to draw in the cyclic quad so you can see what's going on. But notice we actually want the combined angle here and here together. So if I draw this out slightly separately, just so you can see a little bit more clearly exactly what's going on, we're focusing on this shape where this angle together is equal to 50 degrees. And we're looking for the angle opposite. Okay, so once you've drawn it out like this, it becomes much more clear that this is going to be a cyclic quad, and then we just do our usual process. So the angle CDE is equal to 180 minus the angle opposite, which is 50, and then that gives us 130, which I did take away correctly this time, again, which is 130. Another short answer question. So again, you can check the mark scheme. Again, this comes from a 2017 paper on the 0607 course. All right, let's go on to a much more in-depth question. So this is your typical paper 4 question, whichever course that you're doing. And A, B, C, D lie on a circle, center 0. AP and BP are tangents to the circle. That's important. So AP and BP are tangents to the circle. And angle APB, this angle over here, is equal to 46. Now complete the statement. The angle OAP, so OAP, remember middle letter tells us where it is, so this entire angle here is equal to 90 degrees, and the reason for that is because this tangent AP always meets a radius, or diameter actually, at 90 degrees. So you ever see a tangent and the radius, the first thing that needs to come to mind is a meet at 90. So angle OAP is 90 because tangent and radius meet at 90 degrees. And this is quite a common question they get you to answer as well. Okay, so key words here are tangent and radius. Make sure you mention that. Now this question from here, we have to work out lots of different angles. So we've got B, I, and 2 here on the other page. You can see part 3, part 4, and then we've got part C after that as well. And one of the strategies I like to use here is just work out as many angles as you can, and then let's see afterwards if it actually fits. And this is a strategy I like to use, particularly on these extended questions, these paper 4 questions, where there's a lot of steps involved, and one of the easiest ways of working it out is just by working out all the angles. The first thing to realize is that it's symmetrical here essentially, so it means that this angle is also a right angle. And that's for exactly the same reason as what we did at the top here. And if I actually finish drawing this out, this is again another quadrilateral. It's what we call a so-called tangent kite. I don't know if your teacher has mentioned that phrase, a tangent kite. What this means essentially, and then you can work it out from angles in a quadrilateral, add to 360, is that this angle and this angle add up to 180. So if I know that, then if I do 180 minus 46, that's going to give me 134. Double check here I'm doing that correctly there, of course. So this equal to 134 degrees, because these two opposites are equal to 180. Once I know that, I can use the fact I did right at the start of this video, which is the angle at the center is twice the angle at the circumference on the same arc. So notice if I take this angle and keep it going, I get two vertices A and B, and this is on the same arc as here. So that means that this angle here is going to be half of this angle here. So if I do 134 and then divide it by 2, you can use the bus stop, whatever you want to use here, you're going to get to the answer of 67. So this angle here is equal to 67 degrees. I think we can work out this angle here because we have a cyclic quadrilateral. This is where color coding really does come in handy. So let's do this in gold this time. So notice if I take this shape, so I'm just focusing on this shape here in gold. This is a four-sided shape with all the vertices on the circumference, which means if I take, let's do this in red, this angle and this angle, these need to add up to 180. So then we get 180 minus 67. and that's going to be equal to 113 degrees. Yep, I'm happy with that. Double checking everything. So that's equal to 113 degrees. Is there anything else I'd like to work out here? I could work out these small angles here. So this angle and this angle here. Because notice these are both radiuses, OB and OA. This is an A at the top here. So this is the same length as this length. So I can work out this using isosceles triangles. So the way I do that is do 180 minus 134. That's going to be equal to 46. And then to work out one of these angles, we just then do 46 divided by 2, which is equal to 23. So this angle here is 23 degrees. This angle here is also 23 degrees as well. Is there any other angle that comes to mind to work out? Probably, if I thought about it, I'd probably work out this angle as well. But I'm going to leave it like that for the time being and see how much I've worked out. So, angle AOB. Yes, I've worked out angle AOB. That's 134 degrees. Angle OAB. That's the 23 angle. Yep, so I'll put 23 degrees. Such a satisfying feeling when you've worked out all these different angles and you find basically all these angles are the ones you needed to work out. So we've got that perfect. Angle ACB. That's 67, so we've done that one. Perfect. Angle ADB. Yep, we've worked that one out. That's 113. What a great feeling that is. So notice just by working out all the angles I could, I got 2, 4, 6, and then 8 marks just by doing that particular process. Right, and part C, OB bisects angle ABC, find angle OAC. So OB, where's OB? OB bisects angle ABC. ABC. Aha, okay. So it bisects it. Right. So it splits up into two. I guess we have to work out this smaller angle, I'm guessing. Angle OAC. OAC. We need to work out the angle at the top here. Okay, interesting. And then we're told this bisects the angle here. Okay, so slightly different to what's normally expected. I think what I do here, bisects means split it into two equal parts, so this has to be 23 as well. It's the first thing that comes to mind. And then I think I would just use the idea of a four-sided shape adding to 360. Now, what do I mean by the four-sided shape? We actually have an arrowhead shape here, so let me draw this out a bit separately so we can see this. So we've got here, here. This is what's called an arrowhead, but it's still a four-sided shape, where this is 134 degrees. We now know this is 23. We worked out this at 67, and we're looking for the angle at the top here, so this is the question mark. Notice we can just work out the angle in the middle here, because we have angles around a point make 360. So if we just do 360 minus 134, again, you can use a calculator for any of this, of course. You don't have to do it old school like I'm doing here. That gives us then 226, double checking. Yes, I'm happy with that. 226. And then angles in a quadrilateral add up to 360. So if I just add together 226, 67, and 23 and add those together, get 6, 1, 8, 10, 1, 316, and then to work out missing angle, I just do 360 minus 316. And that's going to get to my answer of 44 degrees if I take that away. I'm not sure if that's the way the mark scheme would like to do it, but I think that seems pretty logical. Again, I'd include that working I've just done here under that particular section. But just using the idea of an arrowhead is a quadrilateral, like any quadrilateral, adds up to 360. Notice all that hard work of working out all the angles has really benefited me when doing this question. One thing to realize is this word bisects. It's something I didn't really highlight too much. As soon as you see bisects, that just means split into two equal angles. Yeah? So split to two equal angles. Okay, so that's just an important word to be aware of. Okay, you can check the mark scheme. So this is exactly where I picked up all my marks. Do take that paper 4 strategy into account with these extended questions. You can see this is how many marks in total, 6, 7, 12 marks. I would more or less always approach it in this kind of form. Work out the angles you can and then see if that fits into what you need to do.